might look like a group of random objects, but they all have something in common. What is it? They're all made out of minerals. So what exactly are minerals? And what are some common minerals? How do scientists use characteristics to identify different minerals? I am going to answer those questions for you today. This is Mineral Mania. Come on, let's get started exploring. Let's start with the basics. What are minerals? Minerals are solid inorganic substances with a well-defined chemical composition and a crystalline structure. Well, what does that mean? If we break that definition down, we can better understand what minerals are. First, they're solid inorganic substances, meaning they're not a liquid or a gas, and they're not made from living things. Minerals also have a well-defined chemical composition. What is a chemical composition anyway? All things on our planet are made out of chemicals or elements, and they can exist as pure elements like gold or oxygen, or they may be a combination of elements. For example, halite is table salt. Table salt is a mineral made from sodium and chlorine atoms bonded together. Quartz, the most abundant mineral in our Earth's crust, is made from silicon and oxygen atoms bonded together. Each mineral has a different combination of these elements, and that's what its chemical composition is. Minerals also have a crystalline structure, meaning they form crystals. Table salt or halite has cubic crystals, while quartz has hexagonal crystals. Now, we may not always be able to see these crystals with our naked eye, but with the help of a magnifying glass or a microscope, we can see them a lot better. Now that we have a better idea of what minerals are, let's talk about some ways that we can identify common minerals. Most minerals can be identified by closely examining the specimen or by performing some very simple tests on the mineral. One way to identify minerals is using color. As you can see, minerals come in a variety of colors. Fluorite, for example, can be green, yellow, or purple. Feldspar is red to pinkish, but can also be white or green. And pyrite, or fool's gold, has a characteristic brass color. Another characteristic used to identify minerals is luster. Luster describes the light-reflecting qualities of a mineral. It's usually communicated in a single word, like metallic, dull, greasy, or waxy. There are several different lusters that can be used to describe a mineral. Luster is best observed in direct light and on a surface free of any dirt, dust, or abrasions. Magnetite, for example, has a metallic luster, meaning that it reflects light very well. Quartz has a vitreous luster, meaning it has the appearance of glass. Hematite has a dull or non-metallic luster. It doesn't reflect light very well. Talc has a waxy luster, meaning that it looks like the outside of a candle. And gypsum has a silky luster, meaning it kind of looks like satin or silk. Minerals can also be identified using a hardness test. Hardness is measured on the Mohs hardness scale, which ranges from 1, which is softest, to 10, which is hardest. Diamonds have a hardness of 10, meaning they're one of the hardest things out there and they can scratch just about anything. That's why they're often used in drill bits. Figuring out a mineral's hardness is pretty simple. Harder materials will scratch softer materials. So if you have a few items with a known hardness and you scratch the mineral against them, then you can estimate the hardness of that mineral. For example, glass has a hardness of 5.5. Anything that can scratch the glass has a hardness above that. Quartz has a hardness of 7 and can scratch glass. Another characteristic used to identify minerals is streak color. You can test the streak color using an unglazed porcelain tile. Sometimes the streak color matches the color of the mineral, like hematite, which makes a dark red streak. Sometimes it's slightly different, like pyrite, which has a black to brown streak, even though it has a brass color. And sometimes there's no streak, like quartz. There are other properties or characteristics of minerals we can use to identify them. Magnetism is one. Magnetite, for example, is magnetic. Cleavage is another. Cleavage is basically how does the mineral break. Mica has platy cleavage, so it appears in thin sheets. Fluorite and calcite can be fluorescent. These are some of the ways that we can identify minerals.
I hope you've enjoyed learning all about minerals today. But before we wrap up, I want to do a fun activity with you. As we talked about, minerals have a crystalline structure. So we're going to make our own crystals by making our own rock candy. Let's get in the kitchen and I'll show you exactly how to do it.
For this activity, you will need clothespins, wooden skewers, styrofoam cups, boiling water, sugar, and optional food coloring and flavoring extract of your choice. Start by bringing 1 cup of water to a boil. Once your water is boiling, whisk in 1 cup of sugar at a time. Make sure that the first cup of sugar is dissolved before adding the next. While your water is boiling, wet the wooden skewers. Add a little bit of sugar to a plate and coat the skewers with the sugar. Once all your sugar is dissolved, set the pot aside to cool for about 20 to 30 minutes. If you want to include food coloring and flavoring extract, now is the time. Once your sugar syrup mixture has cooled for about 20 to 30 minutes, add it to each of the styrofoam cups. Using the clothespins, suspend each skewer in a cup about 1 inch from the bottom. Make sure that your skewers aren't touching the bottom of the cup or the sides. Cover the cups with plastic wrap or a paper towel and set aside for 24 hours up to 2 weeks until crystals start to form. Once crystals have formed, remove from cup and enjoy.